You'll hear that. So welcome and thank you for attending tonight's installment of Duchess Land Conservancy's Earth Matters webinar series. My name is Brian Strinidi, and I'm the Outreach and Engagement Manager with the Duchess Land Conservancy. Tonight, we are super excited to welcome a longtime friend and collaborator of the DLC, Dr. Dave Strayer, as he discusses the past and future of the Hudson River. Before we get started, my role is to go over the basic logistics about tonight's webinar. After that, our education director, Julie Hart, will provide a brief introduction to the DLC and to tonight's presenter. First, you'll notice you're muted to ensure that there is no interruption during the presentation. Second, the raise hand function is disabled. And that is because we are handling all questions via the Q&A box. The Q&A box is located at the bottom center of your screen, so feel free to enter questions there as we go through tonight's presentation. These questions will be addressed when the presentation is done. If there are a great deal of questions, we will try to combine them based on topics. So closed captioning is enabled for this event. To turn this function on, go to the bottom of your screen and highlight the CC icon and click it. And finally, I would like to hand it over to Julie Hart, our Education Director, who will tell you a bit about the Duchess Land Conservancy, this webinar series, and our guest presenter tonight. Julie.
Thank you, Brian. Good evening, everyone, and thank you for joining us. I'm Julie Hart, an ecologist and educator here at the Duchess Land Conservancy. I think many of you are probably familiar with the DLC, but for anyone who is not, let me give you a quick overview. The Duchess Land Conservancy is a private, nonprofit conservation organization located in the Hudson Valley of New York State, and we are dedicated to preserving the farms and forests, wetlands and waterways, open spaces and wildlife habitats of Dutchess County. We are an accredited land trust, and since our founding in 1985, we have worked with hundreds of landowners and protected over 46,000 acres of land. We want to thank the Molly B. Schaefer Education Fund and Labella Associates for sponsoring this event. So we're really excited about this third season of Earth Matters, our winter webinar series. On the first Wednesday of each month through April, we'll be bringing you a fascinating speaker with lots to teach us. And this season, we are learning about the history and ecology of our own Hudson Valley. I hope that these webinars will help you to see the lands around you in a new way, to read the stories that can be found in the rocks, the waters, and the trees, and to find a new appreciation for this incredible landscape we call home. Tonight, I am especially thrilled to welcome Dr. Dave Strayer, freshwater ecologist from the Cary Institute of Ecosystem Studies, who has very graciously agreed to come out of retirement and be part of our webinar series. Dave is not just an esteemed ecologist, but also an old friend. I used to work at the Cary Institute, and although I never worked in the Strayer lab, I did manage to tag along once with the river crew on a Hudson River sampling transect. And I remember this being kind of a transformational day because I thought I knew the river. You know, I had lived in the Hudson Valley for quite a while. I had been to the river. You can see it from the bridges. I've seen it from the shorelines. I had even canoed across it once. But being in the boat, going miles and miles down the river and doing all of this water sampling along the way, you really get to see the river in a much different way. And I realized just you can see so much about the shape of the landscape and see how the river fits into it. And it was a really, really exciting and transformational day to get to know the river in a new way. So let me tell you a little bit about Dave's background. He's a freshwater ecologist at the Cary Institute and was part of I'm just going to say, legendary team that studied the Hudson River for more than 30 years. Some highlights of his work include measuring the long-term effects of zebra mussels on the Hudson River ecosystem, the ecology and conservation of native pearly mussels, which is a highly diverse and very imperiled group of animals, as well as delving into broader issues in freshwater conservation ecology and invasion biology. Dave is the author of a very wonderful book about the Hudson River called The Hudson Primer, The Ecology of an Iconic River. And he now lives in Ann Arbor, Michigan, where he is, and I quote, trying to finish a book on freshwater biodiversity, which I totally can't wait to read. I hope it's coming out soon. So with that, I will turn it over to you, Dave. I'll stop sharing the screen and you can pull up your presentation.
Thank you, Julie. I can't talk and do my presentation at the same time, so Okay, here we are. Thank you, Julie. Thank you for inviting me to be with you tonight. I love talking about the Hudson, and I'm really pleased to be talking about the Hudson with all of you. I want to be talking a little bit about the changes in the Hudson from the past to the present, and then what we might see going into the future. So these pictures are supposed to evoke the topic of the talk tonight. This is a picture supposedly of Hudson's ship coming up in 1609. I'll be talking about what changes have occurred since the Hudson saw the river in 1609 and 2024. And then the picture on the right, I think, is are imagining what it might be like in, I don't know, the year 2100 in downtown Stanfordville. And I'll be talking about how the Hudson might change in the coming decades. And there have been just really large and pervasive changes to the river over the last 400 something years since Hudson sailed up the river. Way more than I can talk about in 45 minutes. So I'm going to focus just on 4 topics about how people have changed the river's shape and size, how we've changed the kinds of species that live in the river, how we've changed land use in the watershed and how that in turn affects the river, and then water pollution over the last 400 years and some recovery from it. So let's start right in with how we've changed the shape, the physical shape and size of the Hudson River over the last few hundred years. So many of you know that the Hudson is navigable by ocean-going traffic all the way to the Port of Albany. And it wasn't naturally that shape. In fact, Hudson grounded the Half Moon up around Castleton on a mud bank that when he tried to make it through the Northwest Passage in 1609. You can see the extent of these changes in the physical character of the river by comparing the 2 maps that are here on the right side of your screen. I love these maps. The left hand is I think it's about a 5-mile section of the river in 1820, in the year 1820. The right side shows the same section of the river in modern times. This is work that John Ladd and Dan Miller and Chuck Nieder did a few years ago. Those of you who don't know this section of the river, it's up by the village of Coymans. Near the top of the map here, the Mass Pike extension crosses the river. So when you cross on the I-90 extension here, it crosses through here between Shad and Skodak Island. And you can see a very different river in the 2 time periods. In the left-hand map, 1820, this is already after we had started to modify the river channel. You can see the different kinds of water depths here. So the red is land, dry land. The yellow is the intertidal zone. These are areas that would have been dry during low tide and covered by water in high tide. The light blue is water that's less than 6 feet deep, and the dark blue is water that's more than 6 feet deep. And you can see there are some places here where you might have been able even to wade across the Hudson. It was less than 6 feet deep during an extreme low tide. This would have been a boater's, somebody's trying to get commercial shipping through the river. This is a nightmare, right? I mean, you're going to ground your boat. There's nowhere to find deep water. And in fact, you can see by 1820, these black lines here are dikes that were built to divert water out of these side channels and scour out the main channel in the hopes of making it a little deeper. Between 1820 and the present, we've dredged the river to make it suitable for commercial navigation. I think it's a 28 or a 32-foot deep channel now all the way to Albany. And you can see instead of being this complex of islands and shallow water areas, we basically have a single channel here. These islands now are connected to the mainland mostly because we filled in the shallow waters. So you would have had in 1820 a river that was filled with habitats that looked like this. You would have seen a lot of aquatic vegetation, wild rice and spatterdock and cattails and things like that in the shallow water. And these would have been very rich habitats for fish and wildlife. So things like waterfowl and turtles and things like that. And whereas this is what the river looks like now, this is literally a picture up near Castleton in that section of the river that used to be a complicated complex of shallow water habitats. It's now a single navigational channel. There was interest a few years ago in the ecological function of these shallow water areas, and we were able to show that those vegetated shallow water areas are very valuable ecologically by almost any measure. So the series of graphs across the bottom here show the density of invertebrates on the left, the density of fish, and the number of species of fish on the right. In shallow water plant beds in this lurid green color, and then unvegetated areas in the blue. And you can see by whatever measure here, whether it's invertebrates, plant density, there's way more animals living in these plant beds than there are in the deeper unvegetated areas. And this is because the plant beds provide both food and shelter to these animals. And there's also a lot more kinds of fish in these vegetated shallow water areas. Fish like the sunfish. Any of you who are anglers know that, the so-called weed beds are where these fish are hanging out. So these river shallows are very active, ecologically valuable parts of the river. We estimate currently in the modern river, areas that are less than a meter deep, less than waist deep, let's say at low tide, they cover about 15% of the freshwater estuary, but they provide about 2/3 of current primary production in the river. So by any measure, these river shallows areas that were destroyed in the process of converting the Hudson to a navigable channel were very valuable habitats. Because we now understand how valuable these shallow water habitats are, there's been an attempt to repair some of the damage by restoring some of these shallow water areas. So some of you may, the picture on the left is the restoration at Gaze Point up near Stockport, and where they've been trying to reconnect a dead-ended backwaters and turn it into a through-flowing channel to improve the habitat there. The one on the right, the picture on the right is the boat launch at Coimans, at Coxsackie. And this was an eroding shoreline. The traditional way you dealt with eroding shorelines was to put up a vertical concrete or steel wall, which provided no habitat at all. And this is a built habitat here that's designed to both protect the parking lot at the boat launch and provide a little bit of habitat for plants and animals. Our ability to restore these shallow water habitats is limited, partly because it's expensive, partly because when we either fill the shallow water areas to make them into dry land or dredge them to make into deep water channel, that means somebody's using what used to be shallow water areas for their house or for a navigation channel. So we can't just rebuild those areas into river shallows and throw the existing uses out. And then also it turns out to be quite complicated to restore ecosystems to something where they're vibrant and functioning. So for example, this Gaze Point restoration is very much an ecological experiment where scientists and engineers are trying to build a vibrant, productive shallow water ecosystem. And we are still all learning how to do this well. And that lack of knowledge about how to build an ecosystem also limits our ability to restore shallows. So to summarize, the first big change I'm going to talk about, that happened since 1609, is we've destroyed a very large area of shallow water habitats from the Hudson. The number is about 4,300 acres, 7 square miles. That's about half of the shallow water habitats that were in the river. They've been destroyed, converted to navigation channel or dry land. We know that these shallow water habitats are among the most ecologically active and valuable parts of the river So that loss, of that 7 square mile loss, is a grievous loss of ecological function. We're engaged now in modest attempts to restore these shallow water habitats. We'll never be able to get them all back. And the shallows are going to be endangered in the future by rising sea level. They're going to get turned into deeper water habitats just by the virtue of the rising sea level. The Hudson, if you don't know this, is at sea level pretty much all the way to Troy, 150 miles upriver of the ocean. So as the sea level rises, it will drown out these shallow water habitats all the way up to Troy. The second change I'm going to talk about that's been large and pervasive is that we've changed the kind of species that live in the river. We've changed a river that used to be filled with oysters and shad and sturgeon into a river that's filled with non-native species like zebra mussels and water chestnut and channel catfish. This change has been accomplished by two things occurring simultaneously. The first is we've fished out the valuable native species. We've overfished these stocks of fish and shellfish in an unsustainable way, and it's resulted in large losses of some of the most valuable species that used to be in the river. I love this picture. This is of course is an Atlantic sturgeon that was caught by this commercial fisherman down around Tappan Zee, I believe. I don't know. I don't remember the name of the fisherman now, but this is very much a picture of bygone days in the Hudson. Sturgeons used to be very abundant all up and down the East Coast and in the large rivers going into the Atlantic. They were badly overfished in the late 19th century. So this is coast-wide landings of Atlantic sturgeon from 1880 forward to the present. The y-axis is in metric tons. So we're talking about, in the late 19th century, thousands of metric tons of sturgeon were landed every year along the East Coast of the United States. There are gaps in the record here. They didn't record data for every year. So it isn't like the landings went from, I don't know, 1,200 metric tons to zero, back up to 3,000. We just have a gappy record here. But for a few decades, we were landing thousands of metric tons of Atlantic sturgeon from the Hudson and other rivers and nearshore areas off the East Coast of the United States. They were the third highest landings of any fish along the Atlantic coast. So people in those days would have been very familiar with seeing sturgeons at the markets. The sturgeon populations couldn't take that kind of fishing, so they crashed around the turn of the 20th century. You see a long period here of very low landings coastwide. Finally, in the 90s, they shut down the fishery all up and down the East Coast of the United States in an attempt to recover these sturgeon populations. The thought was that maybe 40 years would be enough to bring the sturgeon populations back up to a higher level, and we're in the middle of that sort of recovery period. I'm not going to show you data about that. We have sort of mixed evidence about, we being the New York State DEC, has sort of mixed evidence that sturgeon are coming back in the Hudson. There's some encouraging signs, but it's not entirely clear how the recovery is going. It isn't just sturgeon. Many of the fish that were important commercial fish along the East Coast of the United States were likewise overfished in the 19th and 20th centuries. This is an analysis that Karin Lindberg and John Waldman published a few years ago. On the x-axis are different species of fish that used to be characteristically abundant in the Hudson and other East Coast rivers. On the y-axis is the percentage of the original population that remains by the late 20th, say around the turn of the 21st century. The red line that I've added here, the dashed line, is 10%. And you can see for many of these fish stocks, we're well below 10% of historic levels. We still have a few shad in the Hudson, but historically there were maybe 40 or 50 shad coming up the river for every shad that we see coming up the river today. So these are very large, pervasive losses of many of the commercially valuable fish that people, you know, in our area would have been familiar with having on the table for much of the 19th and 20th centuries. Now, the good news about fish populations is that sometimes we can restore these by wise management. One of the big triumphs, in my opinion, of fisheries management in the Hudson is that New York has gotten together with all the states up and down the East Coast to jointly manage these fisheries, understanding that you can't recover the Hudson straight bass if people are not also acting to recover them in the Chesapeake Bay, in the Delaware Bay, and so forth, all up and down the East Coast. So it's a coast-wide management system. On the graph on the left, you see the striped bass populations along the East Coast. Some of you may be old enough to remember that we had sort of crisis low levels of striped bass in the 80s. And in response to these very low population levels, they instituted stringent management regulations on harvest of striped bass. And you can see that whether you are measuring the number of adult females, which is in blue here, this is the biomass of females, or the number of young, which is in red, you can see that there was this recovery following this imposition of stringent regulations in the 80s. The stock came back up into the desired window of abundance that they were looking for. So that's a successful fisheries management. The bass populations have been declining over the last 10 or 20 years, and there's activities right now to change the harvest regulations again to try to get this population to recover back up towards the target levels. I said this is done across all the states along the East Coast, and that's great. This is not an easy thing. In addition to the problem of having to coordinate policy across multiple states, the local management efforts to manage fisheries can be blunted by these uncontrollable or difficult to control large-scale things like climate change, biological invasions that affect the fish populations, fisheries or bycatch outside an area that's regulated, or the loss of spawning grounds, particularly for these migratory fish. The damming of many tributaries has meant that there's a lot less spawning areas, and therefore the fishery stock, the fish population, is a lot less resilient than it would have been in 1609. At the same time that we overfished stocks of native species, we've been introducing non-native species into the Hudson by careless activities, deliberate introductions of species that we're not really smart enough to understand the impacts of. So for example, water chestnut was introduced deliberately as an attractive plant, as well as accidental introductions in things like ballast water and through the canals where there's no barriers to movement of fish and other species. So what you see on the graph here is the rise in the number of non-native species in the Hudson. This particular tally is for the Hudson and its tributaries north of the Tappan Zee. So this is just the freshwater parts of the Hudson River Basin. You can see that we have up to the present time about 140 or 150 species that we know about that are not native to the Hudson Basin, but are now established in the wild in the Hudson Basin. These include a bunch of fish as well as non-fish. It's striking how linear this trend line is. The slope of the line is about one species per year. So we're bringing in, since about as far back as into the record as we can look, which is in the early 19th century, we've been bringing in about one new species a year. That one new species a year is an underestimate because we know we're missing a lot of the small organisms, and this does not include the marine species that have come in from Tappan Zee south. That invasion rate translates into in preparing for this talk, I looked at my little list of non-native species. There are 34 species now established in the wild in the Hudson River Basin that weren't around when I began working on the Hudson back in the 1980s. So it's a different system than it was when I started working on it. Some of the recent arrivals have been things that have a strong ecological and economic impact. So this is just I just pulled out a few of the species that have arrived since I started working on the Hudson and the year that they were first reported from the Hudson. So we have some bivalves like the zebra mussel, and further downriver the wedge rangia. These are some of the most abundant animals in the river now in terms of how much the biomass, how much weight of the population. Zebra mussels that alone, the weight of the zebra mussels in the Hudson outweigh all of the fish and bacteria and zooplankton and worms and insects and everything else combined. So these are very, very abundant animals, recent arrivals to the river. There's some other invertebrates like the Chinese mitten crab. There's a parasite of eels that's bothering the eels that came in 1997. We have some troublesome aquatic plants and as well as some fish. Most recently, the most recent famous one at least, is the round goby that appeared in 2014. Some of these non-native species can have really enormous ecological impacts. I'm not going to talk a lot about this, but Julie said that I had been part of a team that studied what zebra mussels did to the Hudson. This summarized what we found in the first decade of the invasion. The boxes are different parts of the ecosystem. The size of the box indicates the size of the change that zebra mussels caused. The reds are declines, like on your balance sheet. The blues are increases. And I want you to notice that pretty much everything that we measured about the river changed when zebra mussels came in, from things like water chemistry to the zooplankton up to the fish, the nutrients, everything. Many of these changes were more than 50%, more than twofold. And basically what we saw was a withering away of the planktonic part of the food web that depended on the food that the zebra mussels ate, the phytoplankton, and then a flourishing of the shallow water parts of the food web. Lest you think this is a nice balance here where we got, some increases and some declines, this declining part of the food web is way, way bigger in the Hudson than the shallow water part is. So there's net losses. So if you were to look at the whole Hudson, for example, when the zebra mussels came in, they resulted in a loss of about half of the fish food in the river. So big, big changes affecting a lot of different parts of the river. Now, the sort of good news and bad news is we can stop many of these invasions if we choose to do so. It's very hard to control invaders like zebra mussels in the Hudson once they're established in the wild, but we have good tools for stopping the invasions in the first place. There's a really beautiful example from the Great Lakes. So this again is time on the x-axis on the left-hand graph here. And on the y-axis is the number of shipping-related invaders in the Great Lakes. And you see from 1959, when the St. Lawrence Seaway opened up, you see an exponentially rising number of invaders in the Great Lakes. Zebra mussels were detected, really hit the fan in the Great Lakes in 1988. And the states and the provinces got together and they decided that they did not want to live with these constant invasions into the Great Lakes that were causing all kinds of problems for the economy and the ecology of the lakes. So they got together and they jointly adopted strong controls on ballast water, which is how most of the shipping related invasions were coming into the Great Lakes. And what you can see very strikingly is instead of this graph of invasions, instead of it continuing upward on an exponential trajectory, it healed over. And in the last several years, we now have 0 detected shipping-related invasions in the Great Lakes. They've stopped them altogether. They did not stop commercial shipping. They did not impose overly burdensome requirements on the shipping industry. And this shows that if we choose to control invasions, in many cases we can. it's largely a political problem, not a technical one. Unfortunately, in most of the world, including the Hudson, we have not chosen to engage on this issue of stopping the invasions from coming in. So here's the second summary of plant and animal populations have changed since Henry Hudson came into the river. We have lots of species that were not native that are now common in the Hudson, whereas some formerly common species have been over-harvested and nearly lost. We are engaged in more or less successful attempts to manage these overfished stocks, which is great. We have not engaged nearly so effectively on reducing or managing invasions. The third change I'm going to talk about is land use has changed. The picture on the left may surprise you. This is the Catskills in the 19th century. They were nearly deforested for timber and tan bark and charcoal. And what we think of as a sort of old growthy forest actually was forest, and it was cut and then restored to forest. The reason land use matters is almost all the water that comes into the Hudson falls on the landscape in the watershed as rain or snow, percolates down into the soils, and then runs down into the river. And so what we do in the watershed in terms of land use practices affects how much water gets to the Hudson, how quickly it gets to the Hudson, and critically, what contaminants or natural substances are carried to the river in that water. So I expect, this being the Dutchess Land Conservancy, you're familiar roughly with the sort of broad outlines of how land use has changed in the watershed. This shows 1800 forward to the present. And you see as in 1850 and up to shortly after the Civil War, a large part of the Hudson watershed was cleared for farmland. Peaking just after the Civil War, a lot of this farmland was abandoned. We get the second growth forest coming into the watershed now that we think of as a largely forested landscape. In the meantime, while these land use changes were happening, we also saw this big increase in the human population in the watershed, rising to around 5 million people today. So these changes in land use have had all kinds of impacts on the river. I'm just going to talk about one very striking and important one, and that is the amount of plant nutrients that are delivered into the Hudson River estuary. So the Hudson has been extraordinarily enriched in nitrogen and phosphorus. This comes from sewage, it comes from farm and lawn fertilizers, and in case of nitrogen, a lot of it comes from air pollution that's rained out. And what you can see on these two halves of the graph are the amount of nitrogen on the left and phosphorus on the right that came into the river before Europeans got here. That's in blue. And the amount that's coming in today in red. And so you can see just these gigantic increases in how well fertilized the river is, to the point where in the freshwater part of the river, there's an excess of nitrogen and phosphorus. If you added a little bit more nitrogen or phosphorus, it would not increase algal production in the river, for example. So these are very, very high loadings of nitrogen and phosphorus, which have profound implications for ecosystem functioning. And there is a result of changes in land use. So I'm not going to say anything more about this. You could give a whole series of seminars about how land use has changed the Hudson. But we've changed gross land use from forest to farm back towards forest, and then now urban and suburban. And then there are all kinds of these subtler changes in terms of the kinds of crops that we produce, kind of industries that are in the watershed, the number and position of roads and railroads and so forth, and protected lands. And I only just talked about these large changes in fertilizer inputs into Hudson, but you'd see the same thing with all kinds of other chemical substances that are washing off the watershed. Which leads us to the last change I'm going to talk about, which is pollution. Hudson, unfortunately, is kind of famous for its history of pollution. And there are several classes of pollutants that were dumped into the Hudson in the past that weren't there or were there in very low quantities in 1609. The first really disgusting one was sewage. And so the graph on the left shows the amount of sewage that was going into the Hudson over the course of the 20th century. The line that consists of these circles here is raw sewage. This is just right from your toilet into the river. And you can see that the equivalent of 7 million people of just completely untreated sewage was coming into the river in the early 20th century. By the mid and late 20th century, this got to be a little bit better, but still these funny vertical lines here shows sewage that got only primary treatment, which is not very much. So we had very large quantities of very poorly treated sewage going into the Hudson well into the 70s and 80s, especially around Albany and New York. And it had large impacts on the ecology of the river and on human uses of the river. So the big effect on the ecology of the river is this sewage is really juicy material for the bacteria that live in the river, and they eat up the sewage and consume all the oxygen from the water. And then you get these large fish kills as a result. So we used to have a pervasive large fish kills around New York City and Albany, especially once the weather turned warm for the first time in the springtime. The sewage pollution also resulted in large numbers of pathogens, human pathogens in the water. The graphs on the right, I don't know how well you can see these, but this shows the Hudson around the island of Manhattan, and it shows counts of coliform bacteria on a logarithmic scale. The counts of coliforms determine what uses are suitable for the water. And this black area here, that's more than 10,000 of coliform in the units they measured in. And that means the water is not suitable for shellfishing. It's not suitable for bathing. It's not suitable for fishing. I would say probably shouldn't touch the water or be within a city block or two of it. And that persisted. This is 1972. This is not ancient times. Finally, this sewage was brought under control, and you can see lighter and lighter colors around the island of Manhattan to the point where now much of the Hudson is safe for swimming much of the time. And that's a tremendous increase in the quality of the water. So we saw this with respect to sewage. We saw this time course where the Hudson was pristine in 1609, totally gross by the mid 19th century, and then largely fixed up by the late 20th century. The other famous kind of pollution in the Hudson, of course, is the PCBs. The GE General Electric plants up north of Albany discharged something like 1 million pounds of PCBs into the Hudson in the mid 20th century. And I expect that all of you know that a large part of those PCBs were removed in a very expensive and extensive dredging campaign that finished just a few years ago. The Hudson is still contaminated by PCBs. The dredging didn't by any means get all of the contamination out, but it got some. And then we have other pollutants, metals. For example, the Hudson was badly contaminated with metals. You can see I boxed out here in red the background concentration of a bunch of different kinds of metals. And for those of you who are not familiar with the scientific nomenclature for the metals, from the top to bottom, this is cadmium, chromium, copper, lead, mercury, and zinc. These are all metals that are problematic. They have strong ecological effects. Many of them have really harmful effects on human health. And you can see that by the 1960s, the concentrations of metals in the Hudson sediments were hugely greater than the background levels. Metals end up in sediments. They're not very soluble in the water, so they end up in the river sediments. You can see that A few decades later, these concentrations had declined in the surface sediments because these old metal contaminated sediments were being buried by cleaner sediments coming in from the watershed. And in some cases, we've even gone in and removed metals the way that we dredged out the PCBs to clean up some of the worst of the metal contaminated parts of the river. This is a picture and some data from Foundry Cove. Foundry Cove is down across the river from West Point. It was a longtime site of a battery factory. They dumped all kinds of, especially cadmium and nickel into the river there, to the point where some of the sediments in Foundry Cove were more than 25% metal by weight. So this is spectacularly contaminated. So a few years ago, they decided they would go in and clean this up. They dredged out the worst of the metal contaminated sediments from Foundry Cove and capped them with clean sediments. So the picture on the upper right shows you what Foundry Cove looks like today. And you can see the graph showing how much cadmium is in the surface sediments. And you can see these very high pre-dredging concentrations being replaced by much lower, but still not pristine, concentrations of cadmium in the surface sediments. I think I already said this, the pollution affects how people can use the river, whether you can swim in it and fish in it and things like that. It also affects the animals in the river. The famous example that I think many of you probably heard of, this is a tomcod. It's a native small codfish that lives in the lower parts of the Hudson River estuary. It's very sensitive to polycyclic aromatic hydrocarbons and PCBs, which cause cancers in this tomcod. So that by the time they're 2 years old, most of the tomcod in the Hudson River have liver cancers. So, which is just creepy. So the history of pollution in the Hudson has been spectacular. It was very badly polluted by sewage, PCBs, metals, and other things, which has had both ecological and then sort of human quality of life and economic effects as well. And that we've been successful in reducing or removing some of this pollution from the river. In some cases, like sewage, we just controlled the inputs. In other cases, people have gone in and actively removed the pollution from the river. Now, I don't have time to go through the full catalog of how people have changed the Hudson, but I just want to remind you it extends beyond those 4 categories of change that I talked about. So, for example, there are about 800 dams on the Hudson and its tributaries. So we've dammed up a lot of these. This interferes with the movement of sediment downriver and the movement of fish up and downriver in the tributaries. More than about half of the shoreline of the Hudson itself has been engineered, replacing these ecologically active natural shorelines with more or less engineered shorelines. The worst are probably these vertical steel sheet pile shorelines that have very low ecological value. And then we've built power plants on the Hudson. I know this is Indian Point, which is closed now, but at its peak, the cooling water withdrawals from all the power plants in the Hudson exceeded the freshwater flow in the river. There were very, and still are some, very, very large kills of fish associated with these cooling water withdrawals, and so on and so on and so on. So we've just vastly changed the river. What general lessons can we draw from this litany of change? Well, the first is today's Hudson is a really different river from the pristine river that Henry Hudson saw in 1609. But I want to emphasize that today's river, if you haven't seen it, it's just a wonderful river, and it's extremely valuable in all kinds of different ways. It's valuable to people. So the fact that it's not the same as the pristine river doesn't mean it's useless. One interesting thing is if you look at all the things that people did to the river in the past, these were mostly done without any thought at all to the ecological consequences of those changes. Building the railroad along the river, doing the filling the river, filling the shallows for navigation, introducing species through the Erie Canal. There was never even a discussion in a room about what this might do to the rest of the river. We've done a good job mitigating or repairing some of these past changes. Sewage pollution is an outstanding example, although there are still some sewage issues that we can talk about, but it's a lot better than it was in 1960. And then we have other impacts that continue largely unabated. So another change that's happened since 1609, and it's just in recent years, and this is one of the most important changes I can talk about, is that now the ecological consequences of actions that we take in and around the river are, many of them are understood, and they're most often considered when we're trying to decide whether to do that change or not. So we have a large amount of scientific research on the river, which is summarized in books like this Hudson River Estuary book on the right, or the Steve Stan's excellent book on the river. So we understand a lot about how the river works, and that understanding is built into the management and protection of the river. And those of you who have not seen the Hudson River Estuary Action Agenda, this is really impressive. There's a diverse group of stakeholders who get together, and they set out their plans for what they want to see in the river every 5 years and how they're going to get there. And then if somebody proposes something like, a new power plant or a marina or a new anchorage along the river or storm surge gates off New York City, the ecology of the river is pretty much always considered in decision making. I'm not saying that people always get the decision right, but at least the ecology of the river is explicitly considered. And this is an enormous advance since 1609. And frankly, it's an enormous advance since 1950. Okay, so now into the interesting part, the future. What can we say about the future of the Hudson? Well, probably the only thing I can be sure about the Hudson in the future is it's going to change. And it's going to change in at least 3 ways that I'm going to mention. The first is it's going to change because we're managing it to make it change. And the 2 examples I want to mention about this are fisheries and the reduction of pollutants. So I've already mentioned that we have this interstate fisheries management where we are deliberately trying to go in and bring fish populations up to a given amount, a target amount. And this applies to fish like the sturgeons, the shads, the alewife, blueback herring, striped bass, and we can at least hope that these fisheries will be restored. The same thing with pollutant. There's very active public policy and management designed to reduce inputs of harmful substances from the watershed and from factories and things like that, as well as remediation by removing them from river sediments. So we can hope in this case that we can see some positive changes. We may not hit all these management targets, but at least we're trying, and I think we can expect to see some positive changes in the river as a result of deliberate management. There's a whole other class of changes that we can see coming down the road towards us, but we're not managing them very well, and we don't understand the consequences very well. The obvious ones that fit in this category are climate change. We've known that human enrichment of the atmosphere with carbon dioxide and methane and other greenhouse gases. We've known that is going to warm the climate and cause changes to the climate. We've known that for 30 to 50 years. Certainly we've known it well for 30 years, and we've been very slow in taking action to control carbon emissions into the atmosphere. So we know that we're going to see a changed climate, and this is going to have all kinds of impacts on the river. We also know that I showed you the graph for the arrival rate of non-native species. that we're going to see a bunch more non-native species come into the river. We don't know the exact changes to these because, I'm sorry, I lost myself here, because we don't know how much climate change we're going to see. Though you see, I'm sure you've all seen graphs like these ones on the right, where you can predict, people are predicting future climate scenarios, but it depends on how quickly we get things like carbon emissions and methane emissions under control. And so we don't know exactly how much we're going to see, the temperature is going to rise. We don't know exactly how more severe storms are going to be in the future, and we don't know exactly what the ecological responses will be to these changes. The other wild card here is we don't know how humans are going to respond to this change in climate, especially if we end up having to respond in crisis. So, as an example of this, there's been a lot of talk about storm surge gates or storm surge protection of some kind around New York City. This is something that's actually being considered, I think, pretty carefully at the moment. But you can imagine a case where we might get catastrophic flooding or something like that, and people would get up on their hind legs and insist that we build something to prevent the flooding right now. And those crisis-built projects tend to have poor ecological performance. So biological invasions, I already alluded to this graph. We are, until and unless we do something to control these invasions, we're going to get a bunch more of them. They're hard to predict the effects because we don't know exactly which species are going to arrive next. Some of the species may have large impacts. The species that worries me, especially right now, are these Asian carps, the silver and bighead carps. These are all through the Mississippi Basin. They're on the verge of getting into Great Lakes. And once they get into the Great Lakes, unless we do something about the Erie Canal, they'll move right across the Erie Canal into the Hudson. These eat plankton, and they will make it that much harder for us to recover things like shad stocks in the river. And then the third class of changes that I have to mention are surprises. We always think in today, we're really smart. We're really good about thinking about the future and planning for what's going to happen in the future. We weren't that smart in the past. There were always a few things that we did not anticipate. And I think we can, if we're smart, we will recognize that there are going to be some things that we are not anticipating right now that are going to happen in the Hudson. So we need to plan for what are we going to do about surprises. So I would say the useful responses, especially to surprises, but in general for all of the kinds of changes we can expect to see in the Hudson in the future, is we can continue to study the river. And the reason I say this is that I just told you the river is changing. So even if scientific understanding of the Hudson was perfect in the year 2020, the Hudson in the year 2040 is not going to be the same river. And if we continue to try to manage it as if it was the 2020 river, we're going to make mistakes. So we need to continue scientific study of the river and scientific understanding of the river as the river changes. We need to monitor the river. Right now, there are a couple of monitoring programs. PRECOS and the DEC are monitoring the river. We've lost, with the closure of Indian Point, we've lost some of the most important monitoring of the Hudson River. If we don't monitor the river, we won't know how it changes, and we will miss surprises in particular. These monitoring programs are always threatened by things like budget cuts. And then we need to use the scientific understanding and the monitoring data to manage the river. And this means that we need to have management agencies that are well-funded, and the management people are smart, and they're prepared to shift course. It also suggests an important role for advocacy organizations to push for changes in the management of the river as new challenges and threats arise. And then the one thing I don't really have a good answer, good advice about is somehow we need to get better at dealing with regional to international problems, not just the local one. Our best successes in the Hudson, and not just in the Hudson, but I think in other ecosystems all around the world, are dealing with local problems. A factory that's discharging a pollutant into the river, a dam that needs to be removed or not built in the first place, um, a sewage treatment at a local level. These are things that we're sort of familiar with dealing with now. But increasingly, the biggest threats to the Hudson and other places are from things like climate change and invasive species, which are not readily controlled solely by local actions. So somehow the people in the Hudson who are concerned about the Hudson need to get better at joining hands with other people at larger scales to deal with these larger scale problems. And for me, an important question about the science on the Hudson, sorry, I'm a scientist, so I'm going to talk about science just for a minute, is are we going to have enough research capacity to keep up and provide the information we're going to need about the Hudson to manage the Hudson in the future? I have on the left here the amount of research funding grants that was supported research on the Hudson. I got this a few years ago from Dennis Sikowski. It's not up to date, but what you can see is there's this big peak around the year 2000 where there's a lot of research activity. The right-hand graph is the number of scientific publications on the Hudson. In the 80s, the Hudson River Foundation was formed, supporting funding on the river. The Hudson River Estuary Program of DEC came in, and places like the Cary Institute's Hudson River Program came in. We had this great flourishing of scientific activity output from about 1900 to about 2010. This is really remarkable, and it gave us an extraordinarily good understanding of the river to base management on. This has been declining since, well, about the year 2005, and I'm a little worried that we may lose the scientific capacity to study the river and to respond to threats if we don't deal with this. I don't have as good information about other parts of the sort of management enterprise, but I'm also concerned that as we go into this challenging future period for the Hudson River, will we have enough capacity in places like the DEC? Will places like Clearwater and Scenic Hudson and Riverkeeper and whatever your favorite advocacy organization, will they still be thriving and able to do their good work on the Hudson? And will we continue to be able to engage the citizenry of the Hudson Valley to get up on their hind legs when they need to and protect the river? So as we look towards the future, we're not looking at a future for the Hudson River. We're looking at multiple alternative futures that are possible for the river and for our relationship with the river. And so I'm going to leave you with the question of which future are we going to choose for the river? And that's all I have tonight. I'd be happy to try to discuss some of this or answer questions. Thank you.
All right. Thank you, Dr. Strayer. That was a incredibly realistic and holistic look at the river and the potential responses to impacts, and not to mention the futures we have to see in the river. I really appreciate that. Just wanted to let everyone know before we go into Q&A that we'll be sending a follow-up email with information on Dave's book, a list of useful resources, and the link to the recording of this webinar tonight. And also before we begin Q&A, I want to let you know that next month on Wednesday, February 7th, our next Earth Matters speaker will be Robert Thorsten, professor of Earth Sciences at the University of Connecticut, who will be talking about the magnificent history in Greater New England's stone walls. And we hope to see you all there. So now, if you're ready, Dr. Strayer, we have a great deal of creative and interesting questions that I can't wait to hear your responses to. So we'll just jump right in. The first question we have is, it's kind of two questions. So what was the purpose of building the federal dam on the river near Troy, New York?
Gosh, that's a great question. And I'm not sure I know the answer to that. I it's it's used today as part of a navigation system north of Albany. We don't have seagoing ships going north of Albany, but there's a series of locks and dams north of Albany that provide a smaller navigation channel from Troy north. And the federal dam at Troy um, has got a lock around it, and it makes the water deeper behind, upriver of the dam, as part of the navigation. I don't know. That's a good question. There was a rapids there originally, and I don't know whether it was built for navigation or whether it might have been built to provide power.
Gotcha. Yeah, lots of interesting
I'm sorry.
waterways up near there. No, no worries. There was a second part to that question, and what effect did the creation of the Great Sacandaga Lake and the State Barge Canal have on the Hudson River, if you know?
Okay, I can tell you a little bit about that. The Sacandaga was built as a flood control reservoir to protect Albany, right? And it does not have a gigantic effect on the hydrology of the river. Some of you may know that a lot of rivers have so many dams on them and there's so much flow control that the unnatural flows have had really harmful effects on the ecosystem. So the Colorado River, for example, there's a lot of endangered species that are endangered because of the dams on the Colorado. They don't have a spring flood anymore to trigger fish migration and things like that. In the Hudson, the hydrology is below Albany. The hydrology is close to natural. So what Sacandaga did for the Hudson is it took a little of the peak off the spring floods and protected the low-lying parts of the city of Albany. And it provides a little higher flows during the summer low flow periods. But it's a very subtle change. The Erie Barge Canal and the Erie Canal before it, the Erie Canal was built in 1820, right? Opened. It allowed shipping from the interior out to New York City. And it was only one of several canals that connected the Hudson to other drainage basins. What they do now and what they've done over what they've been all along, besides allowing shipping traffic, is that they allow movement of non-native species. In the original landscape, the different watersheds provided sort of fire breaks for the movement of aquatic invaders. So in the old days, if you had those carp in the Mississippi River Basin, they wouldn't have been able to get into the Great Lakes without somebody carrying them over there. They couldn't swim into the Great Lakes. And then if they got into the Great Lakes, they couldn't get to the Hudson because not unless they crawled over the land. And so when we build these canals, whatever economic benefits we may get, we get an ecological disbenefit, harm, because species can move through those canals. And we've had, starting in the 19th century and continuing right to this day, we have species moving from the Great Lakes into the Hudson through the Erie Canal, from Champlain into the Hudson through the Champlain Canal. And I guess the Delaware and Hudson is closed now, so we don't have species moving through there, but we did in the 19th century. So it's a conduit for the movement of invasive species. There are ways to build barriers on those canals without closing the canals, and a bunch of us have been pushing the state to try to do that on the Erie Canal before before the next 13 bad invaders come into the Hudson. Which is something technically we can do, and we have not had the political oomph to do it.
Yeah, the history of it is really interesting, how changing the hydrology is kind of changing the circulatory system of the landscape in a way.
Right.
So here's another question that's kind of historical in nature. Were there ever any attempts to develop hydroelectric power on the Hudson, either by dam or tidal flow?
We have hydroelectric on the Hudson further up. I mean, look, so regular the Hudson's at sea level essentially all the way to Troy, and so it's not a conventional place where you put a dam. So we don't have any below Troy, but above Troy there's hydropower. There are experiments going on about using tidal power. I've been to at least a couple talks on them trying to put in these turbines that use the river. The river goes back and forth. It runs north for a while, runs south for a while, and so you can put turbines in that generate power there. And there's been some interest in that. At least some of the designs can be harmful to fish, and so there's something that have to be considered ecologically as well as economically. I'm not aware of anybody having installed anything at scale in the Hudson.
All right, thank you. Another question coming in, is there still a viable alewives fishery in the Hudson?
The alewife population, usually the alewife and the blueback are considered together as river herring in the Hudson. That's what regular people call them, river herring. And you got me here a little bit. I haven't lived in the Hudson Valley for a few years, and so I don't know if there's any fishery at all for them. It used to be people were allowed to catch them for bait. They're popular bait for stripers. And somebody in the audience probably knows the answers to this. When I left the Hudson Valley in 2017, you were still allowed to catch a few of them for striper bait, but not for anything else. There's no commercial fishery to eat alewives or anything like that.
Yeah, I know the populations, as I understand, are still quite low.
They are.
I've been volunteering the eel monitoring project at Norrie Point, and it's the highlight of everyone's day if we ever catch a herring, which is not very frequent.
Yeah, you won't remember that, but the graph I showed from the Lindbergh and Waldman paper, the river herring population in the Hudson is maybe a 50th of what it was historically. Mm-hmm. It must have been amazing to have seen these fish in the old days.
Yeah. Now here's a zebra mussel question. I think this is really a clarification. So you had mentioned that they were introduced to the Great Lakes in the ballast discharge. Is that also how they came to the Hudson?
No. Okay, so they probably came on a boat that was fouled, like a barge or just a regular boat, probably through the canal in the late 80s. The first detection in the Hudson was 1991, but there were already millions of animals in the Hudson by 1991, first detection. And they appeared mysteriously in the middle of the estuary. They appeared around Catskill. And so it strongly suggests that somebody brought a contaminated vessel of some kind and then left it moored at around Catskill, in 88 or 89 or something like that. It would have had to come from Lake Erie for the timing to be right. And then we had a secondary invasion in a year or two later by the Erie Canal, where then the mussels came in a second time from the Erie Canal at the head of the estuary around Troy and Albany.
It's a real pivot point right there, up there. Can you talk about the idea of blocking invasions via the Erie Canal and why that matters?
Okay, so I'm going to give you I'm going to answer the why it matters question first, because that's the important. Why bother otherwise. So let's talk about a couple of these fish species that we're at risk of right now. the grass carp is now in Lake Erie, where the river in my background. That's the Maumee River near Toledo, and they are now spawning in the Maumee, and there are large populations in the Maumee and Sandusky and western Lake Erie. And these are fish that eat submerged aquatic vegetation. Some of you know that protection and restoration of submerged aquatic vegetation in the Hudson is one of our big management goals for the Hudson, right? We like those submerged aquatic vegetation beds because they provide food and shelter for waterfowl and fish and invertebrates and all kinds of things. And grass carp are very indiscriminate eaters of submerged aquatic vegetation. So if and when they get into the river, they will complicate at best our efforts to keep those beds of vegetation in the Hudson healthy against all the other threats, including rising sea level and all that kind of stuff. If I was the person managing vegetation beds in the Hudson, I for sure don't want grass carp in the river. My life's complicated enough already. And the other carp species are the bighead and silver carp, which are really, really abundant in the Illinois and the Mississippi River. They're by far the most abundant fish in those systems now. Their DNA has been detected repeatedly in the Great Lakes, and it's a question of whether they're already in the Great Lakes or whether they're going to get in the Great Lakes. The Corps of Engineers has an electric barrier at Chicago in the Ship and Sanitary Canal. They're trying to keep them out of the Great Lakes. And but if I were betting, I would bet that they're going to get into the Great Lakes. And these are plankton-eating fish. And so they've been really rough on all the other plankton-eating fish in the interior rivers. In the Hudson, our famous plankton-eating fish are American shad and river herring, which we've already said we're having trouble with. And again, if I were the fisheries manager, the last thing I need in the Hudson are the silver and bighead carps. So just even for those three carp species alone, the Erie Canal represents a large danger to the Hudson. It's an open door. Now there are a number of, this is getting beyond my expertise because I'm not a marine engineer, but there are a number of kinds of barriers that people build on canals to slow down or prevent the movement of invasive species. One of the simplest is that you can, instead of having a wet lock where you lock a ship through, you have, 100 feet of canal, there's no canal there. And you have a rail system and you dry lock the ship, the boat over. So you get the boat up onto the rail system, hose it down or whatever you use to disinfect the outside of the boat and drop it in on the other side. There are a bunch of other designs. Again, I'm not a marine engineer and I don't know the details of the Erie Canal that well to know which system would work best for the Erie Canal. But I'm confident that there are engineering solutions that can be used to block movement of invasive species through the Erie Canal without closing the canal to boat traffic. And again, there's just not the pressure to do it. And unfortunately, this is the part that to me just brings me to tears, is the pressure will arise when the carp arrive in the Hudson River and it's too late to do anything about it. Then there'll be whaling and gnashing of teeth, and there'll be the state or the federal government will kick in money to control carp in the Hudson River, and it's too late. And so somehow we need to build that pressure to stop the invasions before they start. Sorry, it's one of my sermonettes.
Prevention is the best defense.
Yes.
Now here's a question about what we can do. So what initiatives are there that aim at further enhancing the health and sustainability of the Hudson River, and how can individuals support these efforts?
So I'm really out of touch enough. You maybe, I don't know if Brian or Julie, if you can add to this, but I personally think the advocacy organizations play a really important role, and that's an easy way to get involved. And I'm going to get in trouble because I'm not going to name all of them, but and I don't mean anything by leaving some out. But in the Hudson, Scenic Hudson, Riverkeeper, and Clearwater have all done really good work in the past, and they've been effective and they have good connections. And so any of those organizations, Scenic Hudson, Clearwater, or Riverkeeper, are good places to, put your shoulder with everybody else's shoulder and try to improve the river. The other place that never hurts is to write your representatives and just, tell them you like the river and you're paying attention. And I don't know enough about specific initiatives right now in New York to know whether there's some specific thing for dealing with combined sewer overflows or something like that you should write about. But I will say that in general, the elected representatives don't hear enough from us and, make their life miserable a little bit.
And another suggestion that I would add is volunteering. A lot of those great advocacy organizations need volunteers, and the DEC has a lot of great programs that need volunteers, like the eel monitoring, there's some water quality monitoring. There's a lot of community science efforts where they need folks to get out and collect data and contribute to these ongoing data monitoring sets that we have for the Hudson River and the watersheds.
Yeah. And then even you talked a lot about groundwater, and now that groundwater goes into the Hudson River. Volunteer for your local CAC or join a watershed group or anything like that. And yeah, write letters, be a squeaky wheel.
And I'm being too cynical. The other way is you can write letters of praise to your elected representatives. If they support something that you like, tell them you're paying attention.
Definitely. I like that. Okay. Next question coming in kind of seems like a bit more of a statement, but I think that maybe they want a little bit information if you know any. Years ago, Albany built what they called the snow dock along the Hudson, and they would dump snow from the street removal in the winter off the dock into the river. It was oftentimes loaded with salt spread from the streets, and I believe DEC finally stopped them from doing it. I'm imagining they want to know if there was any research or impact studies from salinization from street salt or anything.
Yeah, that was a common practice. And that's back again to this stage where we didn't think about the river, right, or the ecological impacts. We just did stuff to it. There is a lot of, one of the things I did not talk about under land use, and if Vicki Kelly's listening, she's going to have my head for this. I didn't talk about road salt. And so we apply prodigious quantities of road salt. And the Cary Institute and other people have been working with highway departments to we're not talking about not using any salt and having the roads covered with snow and ice all winter. We're talking about being smarter about how we manage salt and other things in the watershed to have less impact on the river. The Hudson and the tributaries of the Hudson are a lot saltier than they were, 30 or 40 years ago. And in some cases, the salt levels are high enough that they're of concern for the ecology of these systems. So that's another example that I didn't talk about with land use that the statement reminds me of. And we're not talking. Sometimes people think ecologists are saying, "Well, we can't do anything, right? Everything you do ruins the world." But we're talking about being a little smarter, right? And in the case of salt, we can also a lot of times save money. Cut down on the budget to the highway department. And so if we're a little smarter about how we manage the river and the watershed, we can benefit the river, and sometimes we can get other benefits too.
And speaking of contaminants, here's another question. Do you think that PFAS will become of any consequence in the Hudson River in the future?
I don't know. Again, I've been out of the region long enough. I now live along the Huron River, which I always call the Hudson, in southeastern Michigan, and PFAS for sure is a big deal here, and we, it's everywhere, and it's costing us money. In our case, we've had to upgrade our We get our water from the river, drinking water from the river. Ann Arbor gets drinking water from the river. And so we've had to increase our costs of water treatment. So it's for sure a big deal already in a lot of places. We're still in I think, the discovery phase with this one, right? About understanding sources of contamination and fates of the material in nature and the effects.
Yeah.
Yeah, I've been following the PFAS stuff a little bit, and it's almost better to not follow it at some points, I think. um, So the next question we have coming in, might be a little bit challenging for you since you've been removed from the area for a little bit, but will the Hudson get the boat barriers attachments like the Great Lakes in Michigan? Maybe we can rephrase that too. Would the Hudson benefit from boat barrier attachments like are in the Great Lakes in
So
Michigan?
in the Great Lakes, this is ballast water. And so to be clear, ocean-going ships have these large holds that they can fill or empty with water. These are millions of gallons, and they're designed to improve the stability and safety of the ship. It rides better with more weight, particularly if they're not carrying much cargo. And so they take on ballast and discharge ballast according to how much cargo they're carrying. And these are historically they were big floating aquaria, and without treatment, you just would discharge 100. Let's say they discharge 1 million gallons of water from the port of Amsterdam into the port of New York. And so it's a very effective way to move species around. We have federal laws right now on ballast water discharge that have cut way down on the amount of ballast that's discharged into U.S. ports. But there's still a lot of exceptions. So military vessels, for example, I think are still exempt from ballast water regulations. So in the case of the Great Lakes, they were so concerned that they put the hammer down. I mean, there's no ballast water, and because all the ships coming into Great Lakes from outside come through like Montreal, they have a choke point where they can check the ships. It's real easy for them to check compliance on that, or at least the ship owners think it is. And so, yes, we could do better nationwide by removing exemptions that we have right now for ballast water. I think the last I saw was about 80% of ballast water is coming into U.S. ports now is treated, and about 20% falls under one of those exemptions. And we could, if we did better, we would reduce invasions.
Now, here's a question that I think you probably know the answer to this, but can you ever get rid of the water chestnuts? I suspect the answer is no, but could you talk a little bit about the water chestnut situation and what people can do in terms of preventing outbreaks and maybe smaller bodies of waters when it pops up in local ponds and places?
Yeah. So water chestnut was brought in deliberately as an attractive plant. And it forms these big stands along the Hudson. And when you cross the Newburgh Beacon Bridge, if you look in the summertime, you'll see what looks like green scum along the beacon side, and those are big beds of water chestnut. People hate it mostly because it impedes recreational access. You can't walk through it, you can't get a boat through it. It's just a pain in the butt. It also has large ecological impacts, some of which are positive. In particular, there's large amounts of nitrogen pollution that are destroyed in those water chestnut beds. This was Nina Caraco's work at the Cary Institute. So the state, for about 15 years, sprayed 2,4-D on those beds every year, and they got rid of about 60%, I think, of the water chestnuts. When there was in the 60s, there was more concern finally about spraying herbicides all over the place. They stopped doing it. The control measures that people are looking at on the getting rid of it side, there's a group at Cornell that's been working on biological controls, a beetle that would eat it and nothing else. And that's always a possibility. It's kind of a long shot that you get a biological control that is effective against the target species and has no effects on the non-target species. but at least that's something that Cornell's working at, and it's worked for other aquatic plants. So that's a possibility. On the other end, you might think about why you hate water chestnut. And if it's just because you can't get your boat through it, then maybe cutting a channel through it is the way to do it. And so that retains some of these ecological benefits associated with the removal of nitrogen pollution, but allows you to get your boat through. The other thing you can do, which Julie suggested, is that you don't want it in your pond. And so when you move your kayak or your motorboat out of the Hudson, you want to be really, really, really sure you don't have any water chestnut nuts on the, on the gear that you move to another into another pond. So, there actually are some options there. The getting rid of from the Hudson is the least likely of those options.
Yeah, and sometimes that seems obvious when you look out over an expanse of water chestnuts. We need aquatic goats maybe to be
Yeah.
gobbling them up. So I just want to let you know that we are getting close to 7:30 here, and we do have a good amount of questions left. And I do want to shout out that someone put a link after we were talking about advocacy and stuff. An individual put a link in the Q&A down toward the bottom about a riverkeeper action alert urging Governor Hochul to support a barrier in the Erie Canal. So that would be a cool way
Yes.
to right now
Thank-
support the waterways.
Thank you.
So the next question, and I'll let you be the judge of how many more questions you want to take here. But someone had said that they remember reading a study related to a storm surge that moved up the river around the year 1000 that went out and churned up sediment along the river. Could such an event in these times kick up all the PCBs and various other toxic chemicals at the bottom of the river, resetting the recovery clock on the river?
Sure, it could. Yes. I mean, they've removed, well, first off, they've removed a lot of the PCBs from the river, and that stuff's gone. And they've capped some of the others. But you could imagine a scenario where we had a whopper flood or storm surges or whatever that would, stir those sediments back into circulation. So that's always a possibility. Yes. Brian, I don't have anything on my calendar right now, so if you want to continue a few minutes, that's fine.
Yeah, that sounds like a good plan. Maybe a couple more questions, if you don't mind.
Sure.
Cool, thank you.
So there's a couple of drinking water questions here. Your opinion of the present drinking water in the Hudson River. And I know, so a lot of towns are pulling their water from the Hudson, which I think is what this person is referring to.
Yeah, there's a few places, not too many. City of Poughkeepsie and town of Poughkeepsie, that's the familiar local example. I don't have much of an opinion about that, I guess. That, they're required to report. If you go to their the Poughkeepsie water treatment plant's site, they will give you information about what's in the water. I guess I just don't know enough of the details. I think they use, maybe you guys know, activated charcoal treatment, which would remove a lot of trace pollutants from the water if they do. I'm not positive, but that's what we do in Ann Arbor here when we're drinking surface water. River water is always a little risky because people dump junk in the river.
Yeah, certainly. And I mean, the Hudson River especially used to have a lot of lore around it about drinking the river, at least when I grew up. So you had mentioned that sewage was put into the Hudson until the 70s. Was it legal to do so that recently?
Well, it wasn't a secret. I don't know the laws or anything like that, but so I don't know exactly what allowed New York, especially city, to be discharging incompletely treated sewage into the river. And I mentioned that it's not completely solved. There's still some sewage, poorly treated sewage that gets into the river. I mentioned these combined sewer overflows, CSOs. Some systems used to be built where they took in the stormwater and combined it with the sewage and then treated it. And the trouble with that is when you get 6.3 inches of rain, the stormwater system overwhelms, the stormwater inputs overwhelm the system. And the response to that is you just bypass everything and dump everything into surface water, into the river. Sometimes with some rudimentary treatment, you give it a shot of chlorine or something like that and put it in there. So I said to Hudson's, you know, a lot of the Hudson is safe to swim in a lot of the time. When it's not safe to swim in is usually after a big storm, when some of that incompletely treated sewage from these CSOs has come into the river. And I know Riverkeeper that's been one of their issues, that they're trying to get these CSOs dealt with in the Hudson. So we still have some sewage coming into the river and in tributaries. We did the same thing in the village of Millbrook when I lived there. Once in a while it was gross.
Yeah, and I think now is probably one of those times. We had a big snowstorm a few days ago and a big rainstorm last night. So we've had over 2.5 inches of liquid precip. So I imagine those systems are suffering right now. So here's a question about desalination plants. Do they affect fish in the river?
Do we have any? Is there one? There was one proposed for Rockland a few years ago, but
I don't think it
I
got built.
I could be wrong about this. I'm sorry. I don't know. I don't think there are any in the Hudson. And it would depend on the impacts on fish would depend entirely on how they were operated. One of the normal impacts of a desalination plant is that you know, they produce these brines. You take off the fresh part of the water and drink it, and then the real salty stuff goes back in. And so they certainly can have impacts on fish and other parts of the ecosystem.
Sorry, I was muted. I don't see any more. I see one more question that kind of we were talking about water purification and desalination, but so would there be any point in trying to purify a portion of the Hudson, perhaps through a passive system?
The person who asked that is going to have to explain what they mean purify for what purpose. I mean, the Poughkeepsie water treatment plant purifies it so that you can drink the water but they must have something else in mind.
Right. I think it was perhaps when we were talking about desalinization. I could be wrong, but I mean that seems to be the end of the questions there, Julie, if you wanna take us out.
Yeah, I think we have got our way through the question list. Thank you everyone for joining us tonight, and thank you for typing in such wonderful questions. This has been a great conversation. I think I've learned as much from the Q&A as I did from the presentation itself. It's
Certainly.
wonderful to have this back and forth. So thank you so much, Dave. It's wonderful to see you again, and it's been an amazing journey with you up and down the river and learning about the past and future of the river. We're so grateful to you for being here. And thank you all for coming out tonight, and have a great night. We'll sign off, and you will be receiving a follow-up email with some resources in the next day or so.
Night.
Thank you, Dr. Stare. Thank you, everyone.
Good
Good night.
night.